My name is Olga Menagarishvili, and I'm from the Department of Technical Communication and Interaction Design of Metropolitan State University in St. Paul, Minnesota. Rikki, do you want to introduce yourself?
Yes, I'm Rikki Wagstrom, also from Metro State, and I'm a faculty member in the Mathematics and Statistics Department. And we are happy that you joined us today for our presentation. Oh.
The topic of our presentation is integrating technical communication into a math modeling course.
There we go. 1 second here, everybody. Okay, for some reason my screen froze for a moment. Okay. So why did we decide to integrate technical communication into our mathematical modeling courses? The Mathematics and Statistics Department at Metropolitan State University has an industry advisory board that we formed about 4 years ago when we were doing some major revisions of our major programs. The industry board consists of representatives representing many different local industries around the Twin Cities area. And about 3 years ago, we had our board members do a survey. It wasn't a formal survey. This was done during one of our board meetings. We just threw out a question to our board members. We asked them, what non-technical skills do you value in your employees? And when you're interviewing for positions, what kind of skills are you looking for in your new hires? And the board members really settled on 4 non-technical skills, and they all fall along the lines of communication. So we're talking about communicating technical and non-technical information to diverse audiences, diverse stakeholders usually, making effective PowerPoint presentations, project managing, working with organizing large projects with multiple objectives, multiple people, timelines, etc., and working effectively in a team setting. So we wanted to integrate these non-technical skills, communication skills, into our major programs. And we decided on mathematical modeling because these are skills that are commonplace in pretty much every significant math modeling endeavor. Any large modeling endeavor will have these features. So then why co-teaching? So as math faculty, of course, all of us value strong communication skills. We all try to be strong communicators within our discipline, right? We're educators. We try to convey ideas to others in as clear a way as possible. When we write papers, when we give presentations, we value strong technical communication skills. We also want to see it in our students' work. It's important that our students learn to be strong communicators as well. But I have struggled for many years because I have no background. I have no experience in terms of teaching technical communication. I have no background in best practices for technical communication pedagogy or assessing technical communication. My approach was wing it. Do what seems to make sense in the moment. And sometimes I would have some successes and sometimes I wouldn't. And sometimes I would spend countless hours editing and working on student papers. And I always thought there must be a better way. So I wanted to bring in someone with expertise in technical communication to teach me, to be really a mentor for me. Additionally, though, technical communication is a key learning objective in our math modeling courses. And if we're really going to be teaching technical communication, from the standpoint of the students, it adds considerable credibility to the content when you have a tech comm expert who's teaching you that content as opposed to your math prof. So I thought it would add some credibility from the student perspective. We decided to do a major integration of technical communication into our advanced math modeling course. This is a course that's taken by students that are working on math BAs and also industrial and applied math bachelor's degrees. The course is completely project-based. The students work on 2 projects, a smaller project that they work on independently, and then a much larger project that would be appropriate for a team setting. So the first project is roughly 5 weeks of the course, and the second project occupies about 10 weeks of the course. To give you a sense for how we logistically integrated technical communication instruction over the course of the course, I laid out one slide here that sort of shows how the course was organized. The course was divided into 3 parts. Each part was about 5 weeks long. Our semesters are 15 weeks. In part 1 of the course, the first 5 weeks of the course, students were working on project 1. And in project 1, oh, this is interesting. This is an older version of the presentation. I'm not sure why it's showing an older version. Anyway, in part 1 of the course, students are working on project 1. And project 1 is meant to be a fairly small contained project that students can complete by themselves in 1 or 2 weeks. In this case, I chose an optimization problem. It was effectively a minimum covering problem where a franchise is looking to expand their market to the greater part of the continental US, and they want to determine optimal new locations for stores subject to a variety of constraints. It's a relatively small project, a little bit bigger than what they would have seen in one of their optimization courses, but still a fairly small project. They completed that project, like I said, in 1 or 2 weeks. And then during that first 5-week period, we used that time to discuss key concepts in technical communication, development of writing skills and visual communication skills. And then the students applied what they learned to their first project. In parts 2 and 3 of the course, students were working on their second project. This was their team-based project. In weeks 6 through 10, that's when students were actively doing their modeling, analyzing their model. That was really the problem solving segment for project 2. Project 2 in that semester was a problem. They were given a wealth of data on customers coming into a local coffee shop. Actually, it's a cafe, and they were studying cues associated with the barista and coffee orders in particular, because in this particular cafe, it tended to get really crowded with people standing around waiting for their coffee orders to be filled. So that was the context for the second project. So during the first 5 weeks that they were working on the second project, we used that time to also introduce development of teamwork skills. And then in part 3 of the course, the last 5 weeks, students were effectively done with their analysis of the model, and we used the next 5 weeks to really focus on communicating their findings. So in that latter part of the course, we focused on development of team writing skills and also development of oral presentation skills. Olga, do you want to take over here?
Sure, of course. I will now talk about how we integrated technical communication into each of the 3 parts of this course. But I have to preface by saying that this way of integrating technical communication in a course, unfortunately, is not a universal recipe that would work in all contexts. You need to have a technical communication expert analyze the original course and make decisions on how technical communication could be integrated in that particular context. So the expert would look at the course level, the course content, the type of students, the number of students, the course modality, things like that. So I analyzed this course, and this is how we did it in this particular context. So unfortunately, this is not a universal recipe, so to say. So in the first part, as Rikki has mentioned, we focused on communicating in writing and visuals. It was about project one. Students were working on project one, and from the technical communication perspective, we had to establish a base and talk about the basic notions of technical communication that were used throughout the whole semester. So in that particular course, we discussed two notions, that was audience and purpose. And they're very important in technical communication because in order to create a document that a certain audience finds persuasive, you need to analyze the audience first. So the reader is always in the center. And also you have to keep the purpose of your document in mind so that in the end, the final version of the document actually fulfills that purpose. And that means that in this class, we looked at several different types of documents, discussed who the audience is and what the authors did to adjust that document to that audience and what the purpose of those documents was. In terms of development of writing skills, we had three subtopics in this part. The first one was peer review. And that's important because in the workplace environment, you get feedback on your document from several different groups of people. So peer review becomes this essential skill that you are using in order to improve your documents. And in this part of the course, we talked about different types of peer review, different techniques of peer review that students could use, and then they actually applied it as they were working on their project one. The next topic was writing effective prose. That's creating text that works for a certain audience and for a certain purpose. We looked at the document structure, we looked at paragraph structure, sentence structure, things like that. So that was the textual side of things. And then we also discussed several technical communication genres that are common for mathematics. So again, a lot of information came from Rikki. We looked at some sample documents. More specifically for project one, the students had to create a technical report and an executive summary. And we looked at some sample technical reports, some sample executive summaries, looked at some similarities between them, and then the students had to produce their role. In terms of developing the visual communication skills, we talked about the visuals, the graphical side of technical communication. So usually text and graphics, text and visuals are the two sides that are discussed in many technical communication classes. And in terms of visual communication, we discussed document design, that is how things look on a page, what kind of information can be highlighted, what kind of information can be hidden, things like that. And then also reader-centered graphics. So we discussed what kind of graphics are used in mathematics, what kind of graphics our students could use in their documents, and how to create persuasive documents using graphics that are easy to read for certain types of audiences. Slide, please. Rikki, slide, please.
It's sticking.
So this was part one.
There.
Part two was about problem solving in teams. As Rikki has mentioned, this was the part of the course in which our students started working on their project two, which was a more extensive one. And that was also a team project. Also developing teamwork skills became very important. And we focused on the following subtopics in this part of the course. The first one was collaboration. How do you collaborate in a team? Then project management. How do you manage a project in a team? Revising in teams. What are some revision techniques that you could use to revise your document to make sure that the final version of the document is effective? So in technical communication, writing is viewed as a process, so we always emphasize that it's important to create a series of drafts. to make sure that the last one is better than the first one, so to say. Another topic was communication styles in teams. And here we mentioned that in different teams, different communication styles can be present. And what can you do? How can we effectively work with some of these communication styles? And then finally, we discussed troubleshooting team problems. We looked at some typical problems that some teams may have and ways of troubleshooting them. And here students had some readings. They also had some videos to watch. And then we asked them to complete some exercises based on the information that they were getting from the readings and the videos. So this was more of a preparation stage for part 3 in terms of teamwork. Slide, please. Part 3 was about team writing and presentation. And this is the part in which the students combined everything that they have learned in this course so far in terms of technical communication. So they could apply their writing skills, their visual communication skills, and their team working skills. They were still working on project 2, but this is when they were communicating the results that were connected with project 2. In terms of development of team writing skills, they had to create 3 different types of documents. So again, 3 different technical communication genres. The first one was code/spreadsheet. They had to go through several drafts, and Rikki was giving them feedback on that. This was the math portion that I could not comment on, but I did comment on the final version of their spreadsheet. And we talked about what was persuasive, whether their document was easy to search in terms of visual design, if it was effective or not. The second document they had to create in connection with project 2 was a technical report. They had to write a rough draft, then they received some feedback from us, their instructors, and then they had to improve it, make some changes to it, and then they submitted the final draft that was actually graded. And the same applied to the executive summary that they had to write. Also, they created a rough draft. We gave them some feedback. They made some changes, and then they submitted the final draft that was graded. This was the writing portion and the visual communication portion. And then we also asked our students to naturally present their project too, and that was their opportunity to work on their oral presentation skills. And we had 2 subtopics here. We talked about creating presentations for a specific audience and purpose. And then the second one was designing effective slides. So each student had an opportunity to design sample slides. Then we gave them some feedback on those slides, and then they used those skills to work on a collaborative oral presentation during which they had to present their project too. Slide, please. Okay, Rikki asked me to add a slide on assessment of technical communication skills because we thought this audience might find it interesting. Again, this is the types of assessment that worked for this particular course, so this is not a universal solution. In this course, we used the same grading rubric for both instructors, so Rikki and I were working on the same document, but some grading criteria were strictly math grading criteria, other grading criteria were strictly technical communication grading criteria, and yet the third group was an overlap, so we both contributed to those, and then the student received a grade based on the results of our discussions. Here we have some sample technical communication grading criteria categories. So that's the part that I graded. The first one was, of course, rhetorical awareness. That's the #1 priority in our field. Again, the document has to be persuasive, has to work for a particular audience, for a particular purpose. So I looked at that. The second one was content. And here I graded this, but Rikki also contributed in many respects, because this is when we looked at whether the student included the necessary information in the document and how much of that information was included. The design was the visual communication side of things. What did the page look like? Did all graphics look okay? Were they persuasive for this audience? Were they effective? And then prose is connected with text naturally. How did was the structure or the text structure clear on the document level, paragraph level, sentence level, things like that? Slide, please. Rikki, your turn.
Sorry, everybody. Sorry.
And we're going to talk about the lessons
There
that
we go.
learned.
There we go. Sorry, I'm a bit flustered by the fact that somehow we have a different version of our presentation than the last version I had saved, and I'm still pondering that in my head, so I'm a little bit flustered. Anyway, lessons learned. This was really valuable for me as a math faculty member. Like I said, I really never knew what best practices could look like for technical communication. I did not know how I should go about doing this, really. So Olga was a great mentor for me in terms of showing me instructional methods and pedagogy that can work. Olga has also said this isn't a universal, it's not the way to do this, but it was a way, and it was very helpful for me. It was also very helpful to see how she would go about assessing technical communication skills, designing a rubric, an appropriate rubric for technical communication skills. And also, I've done peer review in other courses before, and I haven't been overly impressed by how that's gone. Although I like the idea, it hasn't always gone very well. And so learning how to make better use of peer review was for me very helpful. Olga, do you want to say a little bit?
Technical communication side of things. This was my first time working with math students, which was fascinating. I had worked with computer science students and engineering students before at other institutions. And I think I've had, one or two math students in the mixed section that would have majors from different fields. But this was my first time working strictly with students from the Department of Mathematics, and that was fascinating. I really enjoyed that. And then another part that was new was working with a small class in technical communication, which again is a separate academic discipline that has its own PhD programs, conferences, publications, etc. We usually have 20 to 25 students per section, and this is the size I was used to. Yet at my previous institution, I helped create and taught an experimental technical communication course for computer scientists that had 50 students in it. So I went from 50 students to 5 students in this course, which was amazing. The other extreme, and just the richness of material and the amount of information that we could give to each individual student was fascinating. So I love that part. Slide, please. So thank you for your attention. We're holding a breakout session afterwards in the same room, and would be happy to discuss this topic in greater depth with those of you who decide to attend. Thank you so much for your attention.
Yes, thank you so much for coming. And a few of you have commented that it was okay if the slides were not quite the last version. Yeah, and somehow it was sticking. I don't know, I wasn't able to advance slides. So these things always seem to happen to me, and they always happen, of course, when you don't want them to. But yes, thank you very much for coming. Do you have any questions for us?
I have a question about the projects that students were assigned, the first and the second. Were they the same project for the whole class? And was that because the class was only a small class, or would it always be true if you had the misfortune of having 50 instead of 5?
I I like to choose the same project, have students, multiple students working on the same project or multiple teams working on the same project. Because from my experience, one of the richest parts of a modeling course is when students can report out on how they modeled and they see different approaches, right, to modeling the same project. Students tell me time and time again how interesting that is and how valuable that is for them to see different approaches to tackling the same problem. So that it was very deliberate on my part to have students working on the same on the same team project. Definitely. The other for project one, all of the students were working on the same problem. That was intentional also because I wanted them, to have some discussion back and forth about the approaches that they took, although there was far less variability in the approaches that they took for the first problem. It was a minimum covering problem, and they basically all set up their problem as an integer programming problem. They had very similar variables. So there wasn't a whole lot of variability. But they were still able to compare and contrast. I did not check their math initially. I wanted them to check with each other to develop a kind of a community of, okay, I got this, did you get this? And why did we get different things? Why did we get different results? So I wanted them to really interact with each other, I guess, about their different models. And if two students got something different, why did they get something different? And I wanted them to really think that through, rather than me just telling them, oh, you forgot this assumption, or, you didn't think about this possibility or whatever. I wanted them to kind of arrive at that themselves through conversation. Are there other questions? I'll be respectful of everyone's time here.
So if nobody else, maybe I want to ask a very brief one. So what's the units of your modeling? Is that 3-4 units course? Because I'm wondering, maybe you mentioned this, but I missed it. What's the percentage of time you spend on the technical communication instruction or time on it? I know usually modeling class doesn't really have a place you have to reach, most likely capstone or something like that. So you have a lot of freedom, but I just wonder the time distribution of which part is, lecturing about math, which part is students working by themselves, or maybe even lecturing about technical communication, or just time spent on each part, maybe just a very rough idea.
Sure. One thing I should add, this was the advanced math modeling course. We also have an intro math modeling course, and students take both. The intro modeling course is, that's all modeling. That's just all modeling. And I try to introduce little bits of technical communication along the way, but that is really all just modeling. Then there's the advanced math modeling. It's a 3-credit-hour course. And in that course, I would say when we taught it, it was about 50-50, technical communication and modeling. The in-class part, I think in part one of the semester, most of the class time was spent on technical communication instruction. Students worked on their math problem at home, outside of class. They worked on the modeling problem at home. They would bring it to class in the next week, and they would have some time to talk about their problem solving, their model, the solution they found, things like that. But then we returned back to technical communication. In the second part of the course, when the students were doing a lot of modeling and analysis of their model, class time was spent largely, it was free time for them to work. At Metro State, our classes meet once a week for this one meets for 2.5 hours. It's a night class. So students would come and we would talk with them for a little bit about teamwork, whatever topic we were going to talk about for teamwork. But I would say the about an hour and a half or so would have been allocated to them working on their team.
Thank you. Thank you very much. And I also think that's all the time we have.
Yeah.
Thank you so much. It's a brilliant idea. I guess
Thanks
I'll
again for
see you
having us.
around.